So section 6 deals with polynomial and rational inequalities. So let's just do 2 examples of polynomials, and actually we'll do 3 examples of polynomials.
We did this one.
We did. That's I'm going to refresh everybody's heads, and then yeah, we did this one. So go ahead, without looking at your notes, do this one again. We did this one. So what are my procedures in solving this? What am I looking for here? Since it is an inequality, what am I looking for?
Well, the goal is to find this, one side over to the other.
And are my solutions going to be points or what?
Yes. It should be a set of numbers within.
It's a series of numbers, right? Yes, so that's what this is. What's different of doing these as opposed to what we did in the past. So yeah, the first step.
Oh,
Yes.
did you figure out that problem from a couple days ago?
Oh, I didn't look at that now because we've been having meetings about the spring semester because for example, my classes, my Tuesday, Thursday was supposed to be calculus 1 and calculus 2, but my calculus 2 course, the date was wrong. Instead of Tuesday, Thursday, it was Monday, Wednesday. So I had 6 classes on Monday, Wednesday overlapping, and so if we got, yeah. And you wonder because in the past, what it was, all it is just they just copy the spring semester from last year, just change the semester. But for some reason, that one class, the date changed. So I have to now figure out where I'm going to pull up another course. Anyway, so first off, set equals 0. So we subtract x and subtract 3 from one side. So we got x squared plus 2x minus 8, and these cancel, so we have 0. Now, why do we set it equal to 0?
Because we're looking for the one where the y has 0, but we have to find the x in the back.
We're looking to see where this function, well, this one, where is the function below 0? In other words, the function is f of x, which is the y values. Where are the y values below 0, which is where is the graph below the x-axis? In this one, can I use the x-intercepts? Why? We have to find those. But oh, you're saying, yeah, we can use the intercepts because it's equal to. So we're looking at what are my x-intercepts. If that line wasn't there, we couldn't use the x-intercepts. So in this case, once we find our factors, so it's going to be x and x plus and minus. The bigger number is positive, so it's 4 and 2, which means my intercepts are at -4 and +2. So at -4 and +2, are they going to be open or closed circles? Closed circles because it's an equality. Since it's less than, I'm looking at where's the graph below the x-axis. Well, we have to draw the graph. Do we have to look for every point individually? No, we just have to do a rough sketch. What do we know about this function?
It's going down. It's from down.
Well, it's a quadratic, which means both ends point what? Same direction or different directions? Same directions. Do they point up or down? Since it's positive. So from the end behavior, these have to go up. Does it cross or bounce at the x-intercept? Why? Why?
It's odd number.
Well, no, because it could bounce like this. Well, because the multiplicities of these factors are odd. So because of that, we know it's going to. And yeah. And because our y-intercept is -8. That's a good hint. So to answer this question, where is this function less than or equal to 0? It's below the x-axis from -4 to +2. Those are my answers.
Or -4 less than x.
Or, yeah, -4 less than equal to x less than equal to 2. Did we do example 4 yesterday?
We did not.
Okay, good. Because that's gonna take us some time. Let's look at example 4. Solve this polynomial. 3x to the 4th plus 10x is less than equal to 11x cubed plus 4. First step. Yeah, since the degree of this polynomial is going to be what? 4. So we look at the coefficient. Is it positive? Yes. If it was negative, we'd move everything to the other side because we want the leading coefficient to be positive. But since that's positive, we'll move these guys. So we're going to subtract 11x cubed and subtract 4 from both sides. So that gives us 3x to the 4th minus 11x cubed plus 10x minus 4 is less than equal to 0. Do we want the graph above or below the x-axis? Below, since it's less than 0, we want it to be at the x-intercept since it's equal to or below it. So we got to factor this one out. How do we factor this one out?
Look at the constant and the
And that's called what? We're looking for intercepts, which are the zeros. Since we're looking at the constant and the leading coefficient, and in fact, it's called the rational zero theorem.
Yes.
I know, if I had a multiple choice, you can get it. So P represents what? The constant, so it's 4. Don't worry about the signs because that's what the plus and minus is all about. And the Q is the leading coefficient. 3. Now we have to take the factors of 4 and factors of 3. What is 4? What makes up 4? 1 times 1 and 1 times 4 and 2 times 2. So it's 1, 2, and 4. What are the factors of 3? 1 and 3. So remember, what is the rational zero theorem find for us? All possibilities. Yeah, so we go from infinite number of possibilities to this case, how many? 12. We have 3 on top, times 2 is 6, times 2. So we narrowed it down to 12 possible answers. So what does this mean? It means it could be 1 divided by 1, 2 divided by 1, 4 divided by 1, 1 divided by 3, 2 divided by 3, or plus or minus 4 divided by 3. So these are my possible zero values. No, not yet. We do, but not yet. So remember, we had infinite number of possible answers to begin with. We narrowed it down to these 12. Can we narrow it down any further?
Oh, yeah, we can find how many of each there are.
Using Descartes' rule of signs, we can determine how many positive solutions we're going to have. And then we can also figure out how many negative solutions we're gonna have. So this narrows it down even further. So how do we find that? How do we find the number of positive solutions? Yeah, so our polynomial is this. Look at the sign changes. It goes from positive to negative. Is that a sign change? Negative to positive? Positive to negative? So how many positives am I going to have? Very good. 3 or 1. Because why do we subtract 2? Conjugate pairs. Exactly. Beautiful. Because if our answers are imaginary, we have to have conjugate pairs. Or if they're radicals, then they have to be in conjugate pairs. So we're going to have 3 or 1 positive solutions. Now, to find out how many negatives we have, all we do in our equation is the sign in front of the odd exponents. Change those. If the exponent is odd, change the sign in front of that coefficient.
Why don't we change the ones to the ones again?
Because if you put a negative inside there to -2 to the power 4, it's going to be positive. So the even exponents get rid of the negatives. Because remember, what we're supposed to do here, we're supposed to change x to -x. That's what we're supposed to do. And we're supposed to take the -x. This one makes it positive. This one changes negative. Now count the sign changes here. So we have, is that a sign change? No. Is that a sign change? Yes. Is that? So we will for sure have one negative solution. That's perfect because once we find our negative solution, we don't have to do any more negatives. We just have to concentrate on the positives only. Right. So we have non-reals and zeros. What goes up on top is the degree. What's the degree of my polynomial? So we know that if I add up all these numbers going this way, they have to equal 4. So positive numbers, I can have 3 or 1. But the negatives, I only have 1, so those have to stay 1. 3 plus 1 is 4, so I have no more of these guys. 1 plus 1 is 2. That means I'll have 2 non-real answers. And zeros only exist if all of the terms have an x in them. If x is a common factor of all of them. Since it's not, so this we don't have to worry about. Now we start synthetic division. So now we start positive 1. We have x to the 4th, x cubed, x squared, x, and constant. So we have 3, -11, 0, 10, and -4. Only put the coefficients inside there. One times 3 is 3. 3 minus 11 is -8. 1 times -8 is -8 plus 0 is -8. 1 times -8 is -8 plus 10 is +2. 1 times 2 is 2 minus 4 is -2. So is 1 a solution?
Nope.
No, because that's not 0. Let's try -1. Bring the first term down. -1 times 3 is -3. Plus -11 makes it -14. -1 times -14 is +14. plus 0. -1 times 14 is -14. Plus 10 is -4. -1 times -4 is 4. So there's my first answer. And that's the only negative I have. So I don't have to do any more negative answers. All I have to do now is just check the positives. So x equals -1 is one of my x-intercepts. And once you get a 0, you don't have to go back to this original equation. We now only have to look at this part. We have to only look at the bottom part. What's remaining. And since you found a 0 at -1, try it again. Just in case there's multiples. How do we know there's no multiples here? Because we're only going to have one at negative. So we don't have to try -1 anymore because of that, this. But if it said 2 or more, we have to try it again in case it's a multiple. So next we try 2, 4, 1/3, 2/3, and 4/3. So we'll try 2, 3, -14, 14, -4. Going down the first term, 2 times 3 is 6, minus 14 is -8. 2 times -8 is -16, which makes it -2. -2 times 2 is -4. Not working. So do we have to try -2? No. So we try 4. 3, -14, 14, -4. Bring down the first term. 4 times 3 is 12, minus 14 is -2. 4 times -2 is -8. Makes it 6. 4 times 6 is 24. That makes it 20. So that doesn't work. So now we gotta try 1/3. 3, -14, 14. You see how synthetic division, I mean, it's a very powerful tool. It's a lot faster doing divisions, and it's much faster than plugging in numbers into equations. So bring down the first term. 1/3 times 3 is 1. 1 minus 14 is -13. -13 times 1/3 is -13/3. That's a bad sign. Because now what we have to do is make this one, the 14/1, into a denominator of 3. So 3 times 14 is 42/3. 42/3 minus 13 is 29/3. And repeat the process. And we see it's not going to work. So 1/3 is not a possible answer. 2/3. 3, -14, 14, -4. Bring down the 3. 2/3 times 3 is 2. 2 minus 14 is -12. -12 divided by 3 is -4. Times 2 is -8. Plus 14 is 6. 6 divided by 3 is 2. Times 2 is 4. So the second intercept is at 2/3. So now we only have this equation. We have 3x² minus 12x plus 6. We can use quadratic formula. Since they all have a 3 in common, we can factor out a 3. And now we can use that. So where A is equal to 1, B is equal to -4, and C is equal to 2. Negative B plus minus B squared. B is -4, so negative of -4 plus or minus -4 squared minus 4 times 1 times 2. 2 times 1. It's just plug and play for here. Negative and negative makes it a +4. -4 squared is +16. Negative times positive is negative. 4 times 2 is 8 over 2. -16 minus 8 is 8. Eight is made up of 2 times 2 times 2. So as we've been doing all along, since we have 2 of a kind, we can pull out one of the 2's. Now, since on the top, since I have 2 and 4, it's a factors of 2. I can factor out of 2, which gives me 2 plus or minus square root of 2 over 2. So my x-intercepts here are 2 plus or minus square root of 2. Those are my last 2 answers. X equals 2 plus radical 2, and x equals 2 minus radical 2. Again, they're conjugate pairs. Which is why our chart said we could have 1 positive, 1 negative, and 2 non-real numbers. So what do we do next? What did we just find? We found the x-intercepts. So our x-intercepts are at -1, 2/3, 2 plus radical 2, 2 minus radical 2. How many am I supposed to have? I'm supposed to have 4, because my polynomial was 3x to the 4th. So at -1, is it an open or closed circle? It's a closed circle because there's a line underneath it. So it's a closed circle. At 2/3, square root of 2 is it's bigger than 1, because square root of 1 is 1. Square root of 4 is 2. So let's look at 1.2 or 1.3. So 2 plus 1.2, 3.2. 2 minus 1.2, 2 minus 1.2. 2.0 minus 1.2. So 0.8. Is 0.8 bigger than or less than 2/3? 2/3 is 0.6. So 0.8 is there. Remember, our equation that we're looking for is this. 3x to the 4th. No, it's that one. We're only solving for the one that has equal to 0. It's a 4th order equation, so it tells us what about end behavior? Same direction, up or down? since it's positive, we know from here and here, they have to go up. We know my y-intercept is at -4. All of these zeros occur only once, so their multiplicity is 1, which tells us the graph crosses at each of these points. Do we want above or below the x-axis? Because we want, where is the function less than or equal to 0? So it's less than or equal to 0 from -1 to positive 2/3. And then from 0.8 to 3.2. There's my domain. Now for rationals. Any questions about those? Because now we have to start putting everything that we've learned into solving these equations. Rational inequalities. What are rational numbers? Rational means what? What's a ratio? What kind of equation? Fraction. It is a ratio. It's a fraction. So since we're dealing with inequalities, we're looking at two functions here. And we have to set it equal to 0. Now, to help us graph these, we have to find 5 things. First thing, we find the x-intercepts. Second, the y-intercept. Third, the vertical asymptote. Then the horizontal asymptote. And then oblique asymptote. Note, only one of those two exists. You either have a horizontal or an oblique, or neither. So to find my x-intercept, what do I do? Set the top equation equal to 0 and solve for x. Those are the x-intercepts. In other words, for rational equations, x-intercepts are only where the top number equals 0. Where do we find the y-intercept? Set x equal to 0. In other words, what you're only going to have are the constants over the constants. That's going to give you your y-intercept. How do you find the vertical asymptote? Set the bottom equal to 0 and solve for x. How do you find the horizontal asymptote? Look at the degrees of the equations and compare those two. There's only 3 things. Either the top can be bigger than the bottom can be bigger than the top, or they can be equal. And so you have 3 possible conditions there. What's the only one that doesn't work for the horizontal asymptotes? No horizontal asymptote if the top is bigger than the bottom, because it goes to infinity. unless the top is bigger than the bottom by 1. Then we have an oblique asymptote, which means we have to do long division there. So example 5. Here are my polynomials. 3x, let me do the other side. So here's example 5. 3x over x plus 6 is less than 0. First, set it equal to 0. You have to have a 0 on one side. Simplify the other side. In other words, we can have a fraction plus or minus a fraction plus or minus a number. You have to combine those and simplify them. So you have a fraction over a fraction. You're not done simplifying until you get a fraction over a fraction, in this case, less than 0. So are they simplified as far as possible? Yes. Step 3. Find the x-intercept. So here, what is my x-intercept? How do you find the x-intercept? We just talked about that. Set the top equals 0. So we have 3x equals 0. So my x-intercept is at 0. So I set the numerator equal to 0. Next is my y-intercept. How do I find the y-intercept? Set x equal to 0. So we have 3 times 0, 0 plus 6. So the y-intercept is at 0. Rule of thumb, if your x-intercept is at 0, it better be the y-intercept because that's the origin. Third step, find the vertical asymptotes. Set the denominator equal to 0. So we have x plus 6 equals 0, x equals negative 6. So that is my vertical asymptote. X cannot equal negative 6. Horizontal asymptotes. Here, to find the horizontal asymptotes, only look at the leading terms. There's this stuff here you don't need. So we have 3x over x. The x's cancel. They're the same size. So the horizontal asymptote is 3, is the line y equals 3. It's a horizontal line. Because we have a horizontal asymptote, we cannot have, does not exist. We cannot have a oblique asymptote. Let's put this stuff together. So my x-intercept is at 1, 0. My y-intercept at 0. Vertical asymptote 1, 2, 3, 4, 5. -6. So that's my vertical asymptote. Horizontal asymptote is at 1, 2, 3. So there's my horizontal asymptote. And I have no oblique asymptote. So my graph has to fit in 2 of those 4 quadrants of here. Well, how do you test that? Well, first off, since we have an x-intercept here, we know our graph has to be on this one because we have no horizontal intercepts. So this side here will look like this. Now we have to determine over here, does it go on top or does it go on the bottom? How do we know it doesn't go on the bottom below the horizontal asymptote? Is there an x-intercept? There's no x-intercept, so it has to go over here. So far, so good. So that's our graph. Now we have to go back to our equation. We're only looking at for what part? Where it's less than the 0. So it's only less than 0 in this right here. So it's between -6 and 0. -6 is a vertical asymptote, so you cannot use that. 0 I cannot use because there's no equality sign. I cannot use the intercept. So there's my answer. Or -6 is less than x is less than 0. Either one of those, depending on which format it wants. Again, now everything's going to be cramming together when we start using everything we learned. All right, let's look at example 6. X plus 1 over 2x minus 4 is less than equal to 1. First step. Set equals 0. So I move this one over there. How? I subtract 1. So we have x plus 1 over 2x minus 4 minus 1 is less than equal to 0. What's the rule for subtracting fractions? You have to have a common denominator. So this one now is just 1 over 1. What's my common denominator? 2x minus 4. So since that's already there, I can multiply 2x minus 4 over 2x minus 4. Is less than or equal to 0. I have a common denominator, 2x minus 4. On top, I have x plus 1 minus 2x minus 4. Well, for right now, whenever you deal with these terms, make sure you put parentheses around them. If you didn't put parentheses around this 2x minus 4, then this minus would only affect the 2x. It's got to distribute throughout the entire thing. Do we need the first parenthesis? No. Now we distribute the negative sign. So it's minus 2x. Negative and negative makes it a positive 4. Now we're combining terms. So x minus 2x is negative x. 1 plus 4 is positive 5. Any questions about that so far? We're setting up our rational equation. Now we got to look for our x-intercept, the y-intercept, the vertical asymptote, the horizontal asymptote, or the oblique asymptote. Just by looking at this equation, which one is easiest to do without doing any real math? Okay, what would the horizontal asymptote be? Because since the degrees are the same, they cancel out. What's my y-intercept? Yeah, just the constant. So it's 5 over -4, which is -5/4. Since we have a horizontal asymptote, we cannot have an oblique asymptote. 66 or 60% of the stuff is already taken care of for you. How do I find the x-intercept? Yeah, so it's -x plus 5 is equal to 0. So x equals 5. That's my x-intercept. Just take the top, set equals 0. For the vertical asymptote, take the bottom and set it equal to 0. So x equals 2. So my x-intercept is 5. 1, 2, 3, 4, 5. Is it open or closed circle? Closed circle because there's an equality. The y-intercept is -5/4, which is -1 1/4. So it's down there. The vertical asymptote is at 2. Horizontal asymptote is at -1/2. Because we only have one intersecting point here between the horizontal and vertical asymptotes, where are our graphs going to be? Well, yeah, since that's the horizontal asymptote, that's vertical. So my first part of my graph has to look like this. And I'm in the third quadrant because I only have a y-intercept and I can't cross the asymptotes. So there's my graph. That just draws the graph. I haven't answered the question yet. What's the answer to my question?
Has to be, that's greater than 0.
No, it's less than equal to 0.
Oh, not that. I see.
So where's our graph below the x-axis? This whole part here from -infinity all the way up to 2. And then it's right here from the 5 on out to infinity. It's below the x-axis. So it's from +5 to infinity. Because I can use my intercept. I cannot use 2 because it's an asymptote. Any questions about that? Now we're going to open the can of a bigger question. But this is the last one for this chapter, actually. Example 7. Solve this one. x minus 3 over x plus 4 is greater than equal to x plus 2, x minus 5. So the first thing you have to do is what? Besides write it down. Set it equals 0. So which side do we move? It doesn't matter which side you move, really. It's going to give us the same answer.
Let's move the right side over to the left.
Yeah, but typically we set 0 there. So we move this one to that side, which means we have x minus 3, x plus 4 minus x plus 2, x minus 5. Remember, put parentheses around all of my terms. So it's greater than equal to 0.
Negative.
The negative stays it separates right now because we have to do what first? Get a common denominator because we're subtracting two fractions. This one has an x plus 4, so this one needs an x plus 4 over x plus 4. This one has an x minus 5, so the other side needs an x minus 5. So now we have a common denominator on the bottom. And on the top, we have x minus 3 times x minus 5 minus x plus 2, x plus 4. Now what do? We have to get rid of the parentheses. So we have to multiply these two together, and leave the bottoms alone.
Wow.
Don't multiply by, because this way we know what our vertical asymptotes are. It's already factored. So we will leave it there so we don't have to do anything. Because if we multiply them together to find the vertical asymptotes, we have to solve them and factor them out again. So it's already there. Only do the tops. So we have x plus 4 on the bottom, x minus 5 on the bottom. So the first bracket, x times x is x squared. Negative 5x, negative 3x makes it negative 8x. Negative, negative makes it positive 15. X squared. Positive 4x, positive 2x makes it positive 6x. I don't need the first parentheses of brackets, so I can just drop those. 8x plus 15. This negative has to be distributed to that second one. So negative x squared, negative 6x, negative 8. Now we have to combine our terms, right? Once we got rid of the parentheses. So the x squares cancel. Negative 8x, negative 6x is negative 14x. 15 minus 8 is plus 7. It's what? That's as far as you can go, yeah. Because you can't combine anything else. We could, on top, we can factor out a negative 7, which would give us negative 7, 2x minus 1, but that's just extra work. It's not really going to do us any good. So now once we have those, x-intercept, y-intercept, vertical, horizontal, oblique. What's my x-intercept? How do I find it?
The numerator.
Yeah, set the numerator equal to 0. So you have negative 14x plus 7 equals 0. Move the 14 over, so 17 equals 14x. Divide by 14, 7 over 14 is 1/2. That's my x-intercept. What's my y-intercept? Only look at the constants. We have 7 on top, 4 and negative 5 on the bottom. So it's 7 over negative 20. Only look at the constants. 7 on top, 4 times negative 5 is negative 20. So that's my y-intercept. What's my vertical asymptote? Negative 4 and 5. Set both of those equal to 0. Horizontal asymptote. The denominator has x is x squared. Top is only x. Since there's more on the bottom, it's the x-axis. It's the line y equals 0, or the x-axis. And so there's no oblique asymptote. Yeah, I should have found some that did. Then we have to do long division. So let's go ahead and graph this now. So my x-intercept is at 1/2. My y-intercept is at negative 7 over 20, which is right about there. Was it negative 10 over 20 would be 1/2, so it's right below 1/2. The vertical asymptotes are at negative 4 and 5. Horizontal asymptote is the x-axis. Here is the exception to the rule. Yes, at some points you can cross the horizontal asymptote because all the horizontal asymptote is only defined by the degrees of the polynomials. There's nothing really being violated there. The vertical asymptotes you can never cross because that's where the bottom is 0. So since we have a y-intercept here and an x-intercept here, no other points inside these two asymptotes, we know that this part of the graph is increasing. Now we have to figure out, is it on top or bottom? How do we know? Well, let's pick a point there. Let's take, this is my asymptote is at 5, so I take 6. At 6, I plug it into this equation and I see if it's positive or negative. So I'm using the equation negative 14x plus 7, x plus 4, x minus 5. So when x is 6, I got negative 14 times 6 plus 7, 6 plus 4, 6 minus 5. I don't care about the number. All I care about is it positive or negative? On top, you have, this makes it negative 84 plus 7. So the top is going to be negative. This is positive. This is positive. So negative divided by positive is negative. So that means down here is where this graph goes. Because the answer at 6 is going to be negative, it's got to be down there. Since we have the middle domain taken care of because of these intercepts, look at the left, look at negative 5. To the left side of negative 4, the other vertical asymptote. So we have -14 times -5 plus 7. -5 plus 4. -5 minus 5. Negative and negative is a positive, so the top is going to be positive. -5 plus 4 is negative. -5 is negative. So it's positive over positive. So the answer is going to be positive. So that means this part of the graph is up here. That's just graphing the equation. Now I got to answer my question. Where is the function above 0? Well, it's above the x-axis from -infinity to -4. And we can't use those. But we can, that's 2/3, isn't it? Let's see, x intercept is 1/2. So it's above the x-axis or equal to from 1/2 to 5. So 1/2 to 5. And I can use a bracket on 1/2 because it's my intercept and I have an equal sign. So there's my solution set. Make sense? Again, once you understand how to graph these, it's just answering the question from there. Do not, when you're looking for these answers, don't get confused between the x-axis and the horizontal asymptote. Because some students will put, this thing is never negative because it's above the horizontal asymptote. No, this graph is above the x-axis at this point. It's below the x-axis from here on out. So it's only the axes we're referring to. End of chapter 4. Now comes chapter 5. Chapter 5 will go a lot faster.